So in the beginning here, we're going to be talking about Boolean expressions. I mentioned Booleans in Monday's content. A Boolean, it's named after George Boole, who was the mathematician, and he was really into logic and kind of first laid out all of the rules that we have for logic statements. And everything that any type of Boolean statement can be simplified down. It can be, solved almost into just a single true or false at the end of it. So whenever we have data that can be represented as true or false, we say that is Boolean data. The data type is called bool, B-O-O-L. And it just stands for something that's true or false. So we have these comparison operators. I mentioned yesterday that a single equal sign in computer science is the assignment operator. Take data on the right-hand side, assign it to the destination that's on the left-hand side. Well, if that is what we use the equal sign for, what operator do we have when we need to actually check for equality? What if I actually want to use the equal sign, right? If I'm asking the computer, are these two things equivalent? In order to do that, we would have to have two equal signs. So one equal sign is the assignment operator, two equal signs actually checks for equality. Likewise, I could say the exclamation mark means not. So if I had not and an equal sign, I would be checking to see if two things were not equivalent, not equal to each other. Less than and greater than are going to work exactly the same as they do in regular math. This is less than or equal to, and greater than or equal to. The reason that we can't really write it like we do in math, you're probably used to seeing like the sign and then a line underneath it. The issue that we have in programming is that that isn't a key on the keyboard. We don't have a way to type that. So the way we can represent it in text that we can, type on a computer is just by putting the equal sign after it, less than or equal to. Okay. You can also write logical operators in Python. You can write them out as words. So that might be a little bit different than some of the other languages that you might have worked in before. Instead of saying, we have like symbols to represent and or and things, you can literally just type the words and, or, and not in Python, which is really interesting because not all languages have that, but I think it's really clear what you mean. And it's just one less thing to have to memorize, right? I already know what and means, so why create a new symbol for it? So that's nice. The logical operator and is true if both of the things are true, right? So I like to tell the story, in class when I'm teaching CS1. I'm like, okay, you have money, right? You can either have money if you were born into it, if you inherited wealth, if your family has money, or if you have a high-paying job. So if you've done something where you've earned the money yourself. There were two different ways that you could have money. So if you were born wealthy and you are a brain surgeon, true and true. Do you have money? Yes, absolutely. You have a lot of money. For or to be true, you only have to have one item true. It doesn't matter if it's this one or if it's this one or if it's both of them. All are valid. As long as one of them is true, the entire statement is true. So if you were born wealthy, but you, sharpen crayons for a living, you still have money because, you came from your family. If you were born very poor, but you are an NFL player, you still have money because you earned some yourself, right? So false or true is still true. True or false is still true. And if both of them were true, true or true is still true. The logical operator not negates whatever you gave it. It just flips whatever the starting stance was. So if I said what is not true, the opposite of true would be false. And going back to the binary numbers that we talked about in week 1, you know, we mentioned before, data is stored in the computer in zeros and ones, right? Where 1 represents I am sending a signal and a 0 represents no signal at all. It's turned off. It's on and off. We kind of also can use the zeros and the ones to represent true and false, where a 1 would be true and a 0 would be false. When you're programming and you give it any non-zero number, the computer is going to interpret that as a true. So if I was asking the computer to make some sort of decision based on whether or not a Boolean expression was true, and I said something like 3 plus 4, well, that is not 0, so it's true. Any non-zero number would be true. You can chain together multiple comparisons in one. So you could check to see, you know, you could have more than one comparison happening in the same statement. And we're going to take a look at a couple of examples of this before I move on to if statements. So I'm back here in Replit. Oh, I thought I already had it pulled up, but I did not. So we'll go ahead and just go back to our Replit website, and I'm going to log in. And I will create a new Python program. I'm going to tell it Python. And this is going to be, what are we talking about today? Conditionals. Python Conditionals is what I'll name my program. And let's do some of those operators that we just saw. Let's take a look at some of these operators. So let's do some of the comparison operators, okay? So is 4 equal to 2 plus 2? Yes, it is. Is 5 equal to 2 plus 2? No, it is not. Is 4 not equal to 4? No, 4 is equal to 4. Is 3 less than 18? True. Is 3 less than or equal to 3? True. Okay. And then let's take a look at some of those logical operators. So what is true and true? True and true, both things are correct, true. Notice the capitalization. You do have to capitalize the true and false values. What about true and false? No, because for and to be true, they have to both be true. They have to both be true. So it's only, you know, you're only gravy if you got both of them, okay? But or is the one where you only needed one and you're fine. So true or true, yeah, we're good. True or false, we're still good. False or false, no, you don't have enough. Okay, I think that works fine. So now let's take a look at some conditional statements. What conditional means is that it doesn't always run every time. It is only going to run, so this line of code is only going to execute some of the time depending on if some certain conditional was met. So here we use the reserved word if. That's a special command. It tells the computer that this is a conditional statement. And then after it, I give it the conditional. So everything that comes after here is what the computer is going to evaluate. It's going to check to see, does this simplify to a true or to a false? I use the colon to tell the computer, okay, this is the end of my conditional statement. And then I indent, I tab over or spaces, not trying to start any fights here. You indent over, and everything that is indented is going to be part of the if block. It's sort of all chunked together there. And it says, if this is true, then do all of these things, all of the commands that are indented over. If it is not true, ignore it and move on with your life. Okay. So that would be if you want it to do something based on one condition. And if that one condition is not met, it doesn't matter. You don't need to do anything. You can just ignore it. But sometimes we want to force the computer to have like a fork in the road. We're telling it, look, you only have two possible paths and you have to pick one. So if the conditional is true, then this is what we want to happen. Else, which means otherwise, if it is false, this is what we want to happen. I'm going to pause and point something out here. When we have the if statement, it has that expression that needs to be evaluated. But when we have the else statement, it doesn't have another expression over here, right? There's nothing else that I need to check to see. The only way the else branch runs is if this guy was false, right? So I don't need a second expression to be evaluated. It's already built in, right? This expression is being applied to both possible branches, okay? So some examples here. Either a number is even or it is odd, period. Those are our only options. A number is even or odd. How could I check to see if a number is even? Well, here's that mod operator that we learned about yesterday. Remember that modulus, the percent sign, says divide these two numbers and then take the remainder. If I divide a number by 2 and there is no remainder at all, that would mean that the number was evenly divisible by 2. Okay, then that's an even number. Else, if that is not the case, if the computer evaluates this expression and it gets a false, then come down here to the else branch. It must be odd. I don't need a second thing here that says, x mod 2 equals 1. I don't have to do that. There were only two options. This was either true or false. Okay. And then the final type of branch that we'll be talking about here is what if I don't have just two options, right? This is like a true false. You got one of two paths. It has to be one of these two paths. That's it. What if there's more than one, right? There's more than two. What if we have multiple possible options that we need to be able to consider? Well, that is where this command elif comes in. If you're familiar with some other languages, you probably know it as else if. Python kind of shortened that a little bit. It combined them. The EL is for else, and then the if is just if. So this is saying if this is true, you do the first thing. The computer is going to evaluate them. It's going to start at the top, and it's going to go down one at a time until it finds one that's true. And the second that it finds a branch that is true, it will run the output for that branch, and then it's done. It'll break completely out of the entire conditional block, and it'll move on. So if x is greater than 0, it will print out x as positive, and then it'll break completely out. It will never even look at these other guys. It doesn't evaluate them at all. It just goes straight down to the end, right? Because it found its true branch and it already did what you asked it to do. So if I ran this with the number 7, it would say, is 7 greater than 0? Yes, it is. It would print x is positive because the X is in quotation, so it would print literally the X. It would not say 7 is positive. It would say X is positive. There is a difference between using the variable name in quotation marks as the literal word, as opposed to using it as the variable where we get the value that's stored inside of it. So here I have quotation marks. I would literally print X is positive, and then I would break completely out and move on. If I ran this with -3, it would say, if -3 is greater than 0, no, move down to the next branch. Consider this conditional. Elif -3 is less than 0, yes it is. I print X is negative, I break out of the branch. If I gave it 0, 0 is neither positive nor negative. So here I would need kind of a third branch. This else is going to be like a default statement. The else branch here is going to run if and only if the computer already evaluated every other branch and found that they were all false. So if none of the other paths, right, if it evaluated all of these expressions and none of them were ever true, then it would run the else branch. So let's do some examples of that. So I'm going to go over here into I'm not going to run in the shell anymore. So let me just kind of clear that. I'm going to come over here and type some actual code in my Py file over here, my Python file. So let's say we're going to get a number from the user. So we're going to say, here's my little comment, get user input. And then remember the command to get information from the user is the word input. And what goes inside that command is the prompt. What do I want to print out to the screen? So we're going to tell our user, enter a number. And then if you remember the way input works, it is going to print this on the screen. It's going to display it. And then it's going to sit and wait for the user to enter in a number, or I mean, it doesn't have to be a number. The user can enter anything they want because we don't have anything checking that they actually entered what we asked at this point. But it's going to sit and wait for the user to enter something, and then it's going to read in their results. So we want to store their answer somewhere. So I'm going to say num is going to equal whatever they read in. Okay. And then let's just print none. What a beautiful program. So if I hit run, I get the prompt, enter a number. I enter my favorite number, which is 9. It prints the number out. Beautiful. Everybody's happy. We're going to make some if statements here. And I'm hoping that a few of you are already, like, you've got like the hair, on your neck is raised up because you're like, oh, it's not right. Like there's a problem here. I'm hoping that some of you have already realized it, but we're going to go ahead and just do it wrong and see the error that we get. And then we'll go back and fix it. So we're going to do some if statements with the number that they entered. So we're going to say, let's tell them you entered. So I want to print this out. So it needs to go in quotes. You entered the number, and then if you remember how to add in a variable name, how to concatenate the variable with the string literal, I'm going to print out exactly you entered the number. I have a blank space there, and then I will join whatever value is stored inside of num. That's going to be the user input. Okay, and then we're going to have print output based on their number. So we're going to have some if statements here. Let's do if it's positive or negative. So if reserved word, notice how the color changed. And I'm going to maybe make this a little bit larger so you can see it a little bit better. So if the number is even, so we know that we can test that by saying if I divide the number by 2 and the result is 0. That would have been an even number, right? And notice that I tabbed over. What do I want to happen? Your number is even. Okay. I no longer want to be tabbed over because this is the only command that I want to run if this conditional is true. Otherwise, if your number is not even, well, I know what that means. Your number is odd. Okay. And then we'll do some really silly ones. Let's say if their number equaled 8. What a silly example. Then we are going to print you entered the number 8. And then we will say elif num equals 12. Then we can print you entered the number 12. And then finally, if none of those things are true, what a very silly example, then we will print you did not enter an 8 or a 12. Okay. Notice that I have 2 equal signs when I want to check for equality. So let's go ahead and run our program. Enter a number. I enter the number 6. Ooh, problem. It says, I tried to do what you asked, but I could not do this right here. Okay. I could not do math with your result because I read in your answer as a string. And so if you asked me to divide numbers by 2, I need it to actually be a number. So if you can remember from the video that we did yesterday, the way you do that, it's called casting. Casting is where I'm going to tell the computer that I want to force the data type that this information is going to be stored in the computer. So print out the prompt, read in their answer, convert their answer to a number. And you don't have to make it an int, you could make it a float or something as well, because maybe you want them to be able to type in numbers with decimals. However, you aren't going to be able to use mod with floats. So we'll just leave it as an int and that's fine. So maybe I should say enter a whole number. That would maybe be some clearer instructions. Enter a whole number. I'm going to enter in a 6 again. And oh, well, we solved one problem and we caused another. Now it's saying that it does not want to concatenate the answer here in our print statement because we have because now we made it an integer and it wants to concatenate strings, not integers. So that's fine. I think that we should maybe, on second thought, I think that we should leave. Let's read this in as num string. Okay, so that way we will have a string that we can go ahead and concatenate. And we will also have a number. So what I did here is I wanted the same information stored as 2 different types of information. I needed it to be a string so I could concatenate it here and print it out, but I also needed it to be an int so I could do math with it down here. So what I did is created 2 different variables. One, leave it as the string. The second one, take that same value and cast it as an int. Okay. So 3rd time's the charm here. When we enter in 6, it says you entered the number 6, your number is even, and we did not enter an 8 or a 12. Fantastic. This time we will enter an 8, which it recognized here in this very first if statement. We'll test it with an odd number, so it does correctly give us the number odd, that the number is odd, and then finally we'll test that we do get the 12. So beautiful. Maybe some silly examples, but here you can see an if else, and an if else branch. So our indentation is important. Indentation is how we show what all is going to be part of it. You know what? I should have shown you an example of indentation mattering. So why don't I say, I want this to print out 2 things. So it's going to say your number is even, and it's also going to say your number is not odd. What a very silly thing for it to do. But if I do this and I give it an even number here, like the number 4, you see how now it prints out both statements, because both of these statements were included in this if branch. However, if I come down here to the else and I wanted to say, you know, print your number is not even, and I've made a mistake. And my mistake is that I only want this to happen. Logically, what I intended to do was that I only wanted this to happen if I entered into this else branch. However, I do not have this indented. So the computer doesn't know that I wanted this to be part of this branch. This is just a regular print statement. It's going to run every time I run this program, no matter what. If I click run and I give it an odd number, well, fantastic. Your number is not even. That is correct. But it's also going to say that even if it is even, this is going to print out every time regardless. If I want it to be part of that else branch, I really do have to tab it over and let it be the same as all the others. So now if I say 8, fantastic, it's no longer printing that out when it should not be. And then we could have it do multiple things. For example, if I say if they're equal to each other, okay, so it's going to start, you know, top to bottom. First thing it's going to say, are they equal to each other? Sure, print it out, they're equal. Else, if they are not equal, there are 2 possibilities. Our first number could be less and our first number could be greater. And how am I going to know which case it is? I need another conditional. I need another if statement. So this entire if else branch will only run if I enter this else branch to begin with. So if I run this program and I give it the numbers 3 and 3, it's just going to print out X is the same as Y, and that's it. However, if I run this program and I give it the numbers 5 and 7, it will say, does 5 equals 7? No, false. Go to the else branch. Is 5 less than 7? Yes, true. Execute this line of code right here, this branch. So you can nest more than one conditional statement inside of each other. And in Python, the way you do that is by indenting multiple times. I will strongly suggest that you make comments to yourself about when you start nesting statements, to try and remember what path you're in and what you were doing there, and what all had to happen to get there. Something, you really do need comments to try and make it clear when you start nesting things, because it's so easy to get lost and confused. So good formatting and good comments are going to really help you out a lot with keeping your code readable. Okay. This would give you an error because this else branch is trying to be lined up with this if statement. And I can't have if, else, else. That doesn't make sense. So I needed this entire branch to be indented over so that it would be lined up with this if statement, right? You can tell if they're on the same level based on their vertical alignment. Okay. And then I think we're almost done actually, but here you can use the try catch command to try and avoid if there is an error. You don't want your program to just completely crash. You want it to be able to maybe like print out some sort of error message, or maybe like give the user another opportunity to try and enter the correct thing. This is kind of going back to what I said a little bit earlier about how, you know, we can ask the user to enter a number, but there is no guarantee they're going to actually listen to us. I mean, we didn't really have any checks in there to see that, you know, they did what we wanted them to do. So if we say, enter a whole number, oh, and my computer is overheating again, so I can't do the example right now. But if we say enter a whole number and they type in, my name is Micah, well, that is what's going to get read in. And right here, as soon as we try to cast it, that's going to throw an error. There is no number that they can try to, you know, cast that to. It wouldn't make sense. So what we could tell the computer is try to read in the information and do the math. And if you throw an error, if you like catch an error, you can say, except if you are not able to do this, well, then let's retry getting their information in again, because something did not go right. And it's very possible that the user did not pay attention to the instructions. Okay. The final thing to talk about with logical operators and Boolean expressions and things like that is this idea of short circuiting. And it says that as soon as the computer knows what the answer is going to be, it can take that answer and get out of here, right? It doesn't have to, it doesn't need to keep evaluating other parts of the expression if they are not going to change the final answer anyway. We're all about optimization and efficiency in computer science. So that why bother doing work if it's not going to have any impact on your end result? So if you evaluate the expression from left to right, and you already know your end value, there's nothing to gain to keep, you know, going on with the expression beyond that. It will short circuit, it will end, it will just give you the result that it already knows. Well, what are some examples of that? How would it know that, how would it already know the answer? Well, we said true and true equals true. So what if the very first thing I told you was false? It doesn't matter what this hand is, right? Whether this is true or whether this is false, nobody cares. The answer is false. So it'll just stop. It won't even look at this side over here. It will ignore it because it already knows the result and it'll just pass it back. And we can do that to avoid errors, right? If I was trying to divide two numbers together and it was possible that maybe the number that they gave me was 0, I could check to see, well, does their number equal 0? If it does, don't try this over here because you're going to crash the whole program. You can't divide by 0. So if it does, immediately it's false, break out, go down to your else statement. Only Chuck Norris can divide by 0. Only if this is true will we even attempt to see if the other one is true or false or not, so we can see if we should, you know, continue with our if statement or not. Okay. The other one that would be short-circuited would be true or anything would be short-circuited, right? Because true or true is true. True or false is true. So it doesn't matter what I have over here. So true or anything is true, false and anything is false. So we don't need to keep going with this. If you have learned some other languages that had a switch case, maybe like Java or C++, please be aware that Python does not have one. So you could either kind of try to like fake it and create your own, or what's most likely is you would just have multiple elif statements. In the elif example that we saw before, we only kind of had one here, but you can have as many elif statements as you need to cover all possible branches. Practice. Thank you.